I would like to invite the next speaker is Dr. Maia Avtandilashvili. She's from USTUR, and her talk will be updating ICRP 70 skeleton weight versus body height equation.
Good morning, everybody. Thank you all for joining us for the USTUR technical session. In my presentation, I will be talking about one of the applications the USTUR data can be used to improve our current knowledge on important parameters which may significantly affect the radiological dose assessment. And just like the previous presentation, it's all about skeleton. Okay, so, oh, sorry. Okay. So we all know that the skeleton is one of the major deposition sites for incorporated radionuclides, so I'm not going to talk much about the importance of the study. For my motivation slide, I borrowed this paragraph from ICRP publication 89, where the committee recognizes that the reference values for selected anatomical and physiological features of the skeleton is useful for the development of biokinetic dosimetric models. And the anatomical feature I will be talking about is the total weight of the skeleton. The currently recommended reference value for the skeleton weight for adult males, which is 10.5 kilograms, is based on the analysis of anatomical data compiled in ICRP publication 70. To derive this value, the committee reviewed the published weights for dissected skeletons of 44 subjects, including 2 USTUR donors. Those were the very first whole-body donations to the USTUR received back in 1980s. And the committee examined the correlation between the skeleton weight and the body height of 31 of those 44 subjects. Why 31? Because the body height values were known only for 31 individuals. And they came up with this very well-known equation, which we at the USTUR used on the regular basis until recently to estimate the skeleton weight for our partial body donors and to calculate the actinide skeletal activities from concentrations measured in selected bones. But then we realized we could do more. Currently, USTUR holds the tissue samples and the data from a total of 40 male whole body donors. And the availability of the most accurate data on skeleton weights from these whole-body donors provided us a unique opportunity to test and update the ICRP equation. So here is some statistic about the USTUR donors. The average age is 78 years. And total body weight is average total body weight 80 kilograms, average height 179 centimeters, and average skeleton weight 9.9 kilograms. And I just should mention that those two USTUR cases used by ICRP are also included in this study because the anatomical data we're using here is slightly different from the values the ICRP used, since more accurate information became available to the USTUR after publication ICRP 70. So, to examine the correlation between the skeleton weights and the body heights, we use the simple linear regression fit. We use this absolutely the same approach as ICRP adopted in publication 70. And here is the, as initial step, we analyzed only USTUR whole body donor data. And here is the fit and the corresponding regression equation. Correlation coefficient came up almost slightly less than the coefficient R by ICRP, which was 0.6. Now it's 0.56. So, of course, after that, we combined both ICRP and USTUR population data, and now the updated list square feet was generated using 69 subjects. And here is the profile for combined population. Average age now is 68 years, average body weight 75 kilograms. Average height came up exactly the reference men's value, 176 centimeters, and the average skeleton weight is 9.9 kilograms. And here is the fit to the combined population and the corresponding regression coefficient. Just on the next slide, I summarized the correlation coefficients for all three feeds, just for you to see any differences and similarities. And again, please keep in mind that both ICRP and USTUR groups, they include two common subjects and two USTUR cases. And as you can see, the feeds are pretty much the same for ICRP and USTUR only. And the slopes are essentially identical, and the central value of the intercept for USTUR population is just slightly shifted down compared to ICRP, but considering the uncertainties, they are the same. But when we combined both populations, the regression coefficients came up different from the coefficients of the subgroups. Okay, up till this point, we were just repeating what ICRP did in publication 70, and then we decided to go further and use multiple regression analysis to fit the skeleton weight as a function of three variables: height, body weight, and age. All three variables showed significant correlation with the skeleton weight, and so here this table summarizes the regression coefficients and the correlation statistics. Correlation is positive with height and body weight, and negative for age, no surprise here. And both correlation coefficient R and the residual standard deviation came up better than for the linear regression fit. And finally, to summarize the work I presented here, we updated ICRP 70 skeleton weight versus height equation for male adults using USTUR data. A linear regression fit was derived for using the population of 69 data points. Yeah, just by combining ICRP and USTUR data, we more than doubled population size. So, and the presented equation can be used to estimate the skeleton weight from the individual's height. But if the data are also available on the total body weight and the age of the study subject, we would recommend using the multiple regression equation derived here. So that's all I had for today, and thank you all for your attention, and I will be happy to answer your questions.
Yes, thank you, Maia. I was just wondering the age range the equation applies. You know, looks like all your
age range is from, so for the combined population is from 25 to 95 years.
Okay, thanks.
My question was, for a reference man, what would be the skeleton weight using the new equation?
Okay, so, yeah, okay, sorry, I didn't.
What is the age of reference?
Yeah, so we just need to calculate.
I know height and weight. What is
Yes.
the age of reference man? If you know, we can calculate it.
Yeah. Yeah.
45, 65, 25, adult.
Yeah. Yeah. Thank you.